So we're going to cover Chapter 4, which is loops and files. So let's first do this. Okay, so when we deal with loops and files, especially with loops, we need to have some way to increment, because we're going to always be incrementing because we have to have some way to get out of the loop. So the very first thing this thing covers is this increment and decrement operators. And so as we covered in the past, we've got number equals number plus 1. Again, it always does everything on the right-hand side first, and then it basically puts it into the variable on the left-hand side. So it's going to add so whatever's in number, it's going to add 1 to it and then put it back into number. Another way to do that, we can do a plus equals 1. So I can do number equals number plus 1, or I can just do number plus equal 1. Same thing with subtraction. I can do number equals number minus 1, or I can just do number minus equal 1. Another thing we can do is just plus plus. I can do number plus plus, that just adds 1 to number. If I go do minus minus, that will subtract 1 from number. So those are some really powerful things to utilize. Yeah, if we take a look at the increment decrement in Java, so expand chapter 4 and the source, and then the chap 4 package, and I look at increment decrement. So, yep, and we got int number equals 4, so we go ahead and declare variable number. We assign it a value of 4, and then I say the number is number, and I will increment the number. I do number plus plus, and it says now the number is number. I will decrement the number, number minus minus, and then it says now the number is. So very simple. Click on it, and sure enough, the number starts at 4. I will increment the number, so it does the number plus plus. Now the number is 5. I will decrement the number. Now the number is 4. Pretty simple stuff, not too bad. Now, one thing you can do is you can actually do plus plus number and minus minus number. It does the same thing, but it works kind of differently. Yeah. So if we look at prefix, I used to have an example of what I can't find it, but there's an example where this doesn't work the way it should. So I can do number is number. I will increment the number plus plus number. Now I will decrement, so it does the same exact thing, except the only difference is it's got the plus plus and the minus minus in front of the variable. So when we run it, same exact thing. Number is 4, increment the number, number is 5, decrement the number is now 4. I think they may have an example in the book. Let me see if it's still there. Yeah, here it is. The difference between postfix and prefix. So if I were to say number equals 4, and then I say print number plus plus, okay, I can actually do that. And over here I can say number plus 4, number plus plus. So let's take a look at the difference between those. So I'm going to do an SYS. You don't have to do this. You just watch. Whoop. Damn it. SYS O control space. And I'm going to do plus plus number. Oops, I spelled it correctly. Ah, damn it. Okay. So I'm going to run it. Let's see what happens. It works just fine. So yeah, okay, the statement that calls us the println method does two things. It calls the println display the value of number and then increments a number. But what happens first? The println method will display a different value if the number is incremented first, if the number is incremented last. Okay. So if in these statements number is incremented 5, the println will display the value of number in 5. For another example, let's look at the following code. Int x equals 1 comma y. So I create a variable x, I assign it 1, I also create a variable y. And then I say y equals plus plus. In the first statement that declares the variable x, and the second does the following. It assigns the value of x to the value of y. The variable x is incremented. The value will be stored, and y depends on the increment, where the increment takes place. Because the plus plus operator is used in both postfix. Okay, so let's take a look at this example. I think this is what I'm looking for. So I've got x, okay, and what's that? This frustrates me. Anyways, so the first statement declares the variable x, which is initialized to 1, and the variable y. In the second statement, the plus plus operator is used as a prefix mode, so it acts on the variable before the assignment takes place. So this code, okay, that's what I'm thinking of. Okay. So I'm going to do this. I'm going to print s by s. I think it's still going to work the same way though. Yeah, it works. I wish I could remember that example. Gosh darn it. Yeah. If right. Right. So it didn't work the way I expected up here, where I did the print plus plus number. It still prints the 5. Yeah, I had an example, and it makes me mad because I can't. Yeah, but you get the gist though. Just like it says here, in this particular example, the y equals plus plus x. It basically says in the second statement, the plus up operator is used as a prefix mode, so it acts on the variable before the assignment takes place. So this basically adds to the x before. So let's do this. So I print XX number. Let's do this. I'm going to do SYSO, and I'm going to do number plus plus. Let's see what happens. So on statement 30, that's a 5. On statement 31, I'm expecting a 6. So let's see what happens. Yeah, that's what I'm thinking of right there. So it prints a 5, and on the second statement, here's what it does. The println prints the number first, then it adds the plus plus. Exactly. You're exactly right. So yeah, we got to be careful when we utilize these things. So the plus plus before the number, if you're going to print it like this, it will do the addition first, then it prints. This one here prints the number first, then it adds to it. So, okay, that's the example I was looking for. Okay, so the first loop we're going to cover is the while loop. And the while loop is what's called a pretest loop. What that means is it will test before it actually goes into the loop. So the loop control structure calls a statement or group of statements to repeat. Now, why the heck would we want to ever loop? Well, if I wanted to do line A multiple times, well, I could just go ahead and type line A 3 times. Well, what happens if all of a sudden I need to change that line to something else? Well, I have to change that in 3 different places. Well, instead of doing that, let's use a loop. Another thing, too, is I don't really know how many times I need to duplicate that line. Do I need to duplicate it 5 times, 4 times. It might depend on the data that's coming in. So that's where the loop comes in. The loop will basically allow us to execute the number of statements, a statement number of times instead of duplicating lines. So we never want to duplicate code. So basically here how it comes in, we got a Boolean expression. And if it's true, we're going to do something. In this case, if it's false, we're not going to do anything at all. So we do have the chance that it might not even do this execution of this statement. Okay? That's, again, we call that a pretest. Before it actually does the statement, it's going to test whether the statement is true or false. If it's true, it's going to execute it. It's not going to execute it. So here's the format of a general while loop. I say while, and inside of the parentheses, I'm always going to have a Boolean expression, some type of expression that's either true or it's false. And if it's true, I'm going to come into the statement. Yeah, and here's an expanded version of that. So let's go ahead and open up the while loop. Let's just go ahead and take a look at it. So while loop.java, so here it is. The class is called while loop. Here's my public static void main. I go ahead and create an int, an integer variable number, and I go ahead and assign it to 1. And it says while the number is less than or equal to 5, we're going to come into this loop. Now, we always want to make sure that we have a way to get out of the loop. So you'll notice that number at the bottom of this loop has an incrementer. So at some point, it's going to make that greater than 5. And once that's greater than 5, we're going to get out of that loop. So I come in, the while loop number. So number is a 1, so that's true. We're going to come into this loop. We're going to print hello, add 1 to number. We come back around, number is now 2. Is 2 less than or equal to 5? That's true. We're going to print hello. We're going to keep doing this. So how many times are we going to do it? Well, it starts with 1, and it says equal to 5. So it's going to do it 1, 2, 3, 4, 5 times. So let's go ahead and run it. And we'll notice that we go hello, 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 hello 5 times. And then outside of that loop, we've got that's all. Now, here's the one thing I want you to pay close attention to. That if we were to put a SYSO here, right here, sys out, and I'm going to just print number, it's going to hold the number 5, correct? Nope, 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 it's going to be number 6. Because, exactly, so it incremented and then it basically got out. Okay, so, hi Brandon. So it went into this while loop, and again, it had to increment that in order. It had to get to a false statement to get out of this loop. So the number had to be greater than 5 to get out of that loop. So that's why it's a 6. We're talking about while loops. Okay, so there's the while loop. And again, just to kind of reiterate, it says that the while loop is a pretest loop. Again, that means that if this is false, it will not go into the loop. This has to be true in order to go into the loop. And we'll see here in a little bit that we will actually have something like that. We're going to say, if there's an error, we're going to give you a chance to fix it. So the while loop is kind of a nice way. We're not expecting you to go into the loop, only if there's an error, so you can fix it, and it'll keep basically doing that until it gets the correct answer, maybe in the correct format. Then it will drop out of the loop and go into the actual code. Right here it says each repetition of loop is known as an iteration. This loop will perform 5 iterations because the variable number is initialized with the value 1, and it increments each time the body of the loop is executed. And the expression less than or equal to 5 is tested. And once it's found false, it will drop out. So here's the example. Here's basically what a flow chart would look like. We basically have our diamond, which is our decision, and it says number less than or equal to 5. If it's true, it prints hello and it adds 1 to number. And it comes back up to that loop, comes back in and text, is the number less than or equal to 5? If it's true, as long as it's true, it's going to keep executing these two boxes right here. Once this is false, it's going to drop out. Like I said earlier, the while loop is a pre-test loop. So if I did this, if I said int number equals 6 and do while number is less than or equal to 5, guess what? Is 6 less than or equal to 5? No, that's false, so it's not even going to go into the loop. Now the one thing we have to really worry about is this infinite loop. That means it's going to go into a loop and execute forever. Well, not forever. It's going to execute as many times as that particular primitive value will hold. If you remember the integer, the int data type, I think it holds the 2 billion range, so it would run a while. So right here, if we did this, now don't do this, just watch me. I'm going to comment out that number plus plus, and I'm going to go ahead and run it. Look at it. It keeps printing hellos, 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 and it will never end. That program will go on forever because there's no way to get out of this loop. Because that's going to stay less than 5 forever. So I have to click on this little red box right here to stop the run of the program. So whenever we design a loop, you always have to remember there's got to be a way to get out. And don't forget the braces with the block statement. A while loop is just like an if statement. If I were to take these braces away, guess what? The only thing that's going to go with the while loop is this sys out. The number plus plus is not part of the while loop anymore. So if I do a Control Shift F, look what happens. It tabs this number plus plus over. And again, if I run it, it's going to basically it's now an infinite loop. Yep, it's back to an infinite loop because this number plus plus is not part of the while loop. So the braces are very important there as well. So we need to make sure that we have those open braces and our closed brace at the end. Now if I do a Control Shift F, yep, you see that. It always puts that brace up there. And now the number plus plus is part of the while loop. Again, I talked about the if statements. I always use braces. People say, you don't need it for just one line, and again, it makes the code a little simpler. But again, I always like the braces because I know where the beginning of the if statement is. I know where the end is. Now look at this. We could do this. I could say while number is less than or equal to 5. Notice I got my open brace. Sys out println hello, and then print. I could have that on one line. So I could do something like this where and this will run just fine. This will run perfect. So I save it and run it. It works just fine. But it's not what we're used to as far as maintaining code. We're used to seeing things kind of played out like this. That's what we're used to, and that's what programmers are used to. And it's easier. It's easier to see what's going on. It's easier to maintain because of a couple things. We got a lot more white spaces in here, so we've got things spread out, so we can basically see more and see. We have each statement on its own line and not conjumbled together because that looked like one statement when it's actually two together. It works. Okay, so here's another in the spotlight. This is designing a program with the while loop. A project currently underway at the Chemical Labs Inc. requires that a substance be continually heated in a vat. A technician must check the substance every 15 minutes. If the substance temperature does not exceed 102.5 degrees Celsius, then a technician does nothing. However, if the temperature is greater than, or it says does not exceed 102.5, but if it gets greater than 102.5 degrees Celsius, the technician must turn down the vat's thermostat, wait 5 minutes, and check the temperature again. The technician repeats the steps until it does not exceed 102.5. So here's the algorithm. We prompt the user to enter a substance temperature. We repeat the following steps as long as the temperature is greater than 102.5 degrees. Tell the technician to turn down the thermostat, wait 5 minutes, and check the temperature again. Prompt the user to enter the substance temperature. After the loop finishes, tell the technician the temperature is acceptable and check again in 15 minutes. So let's open up check temperature. Let's take a look at it. So here it is. Notice we've got some documenting comments up here. Here's our check temperature class. Here's our public static void main. We've got a final, so we have a constant called max temp 102.5. We create a variable temperature. It's a double. We have a scanner keyboard, and then we do a print. Enter the substance Celsius temperature, :space. And then we use the keyboard.next double to put that into the temperature variable. Now we've got while. While temperature is greater than max temp, we're going to say the temperature is too high, turn the thermostat down, wait 5 minutes, then take the Celsius temperature again and enter it here. And then we say, you notice this is a print. It says temperature equals keyboard next double. And we're going to basically put a new temperature in. We're going to come back up here to the while loop and check, is it greater than the max temp? If it is, we're going to come back into this loop again. And we're going to keep doing this until temperature is less than or equal to the max temp. Okay? So let's run it. And it enters the substance Celsius temperature. Let's go ahead and type in 107.2. We hit the enter key and it says the temperature is too high. Turn down the thermostat, wait 5 minutes, then take the Celsius temperature again. Enter it here. Okay. Now it's 105.7. Oh, it's still the temperature is too high, so we turn down the heat. We wait 5 minutes, we type in it again. Now it's 103.6. We hit the enter key. Now we got to wait, turn it down, wait 5 minutes, and now it's 101.2. We hit the enter key and it says, the temperature is acceptable. Check again in 15 minutes. Now it's pretty generic code, but as far as how the looping process goes, think of this being more automated, where it's actually got a sensor that basically goes out and checks the temperature exactly from the actual device, the vat. And we have a timer that sets for 5 minutes. So we might have a process where it says, hey, turn it down. So we turn it down a little bit. The timer starts clicking off. And after 5 minutes, it actually goes and reads the vat temperature again. And if it's basically too hot, it sends that message out and says, hey, turn it down. And once you turn it down, we might even have it hooked up so it turns the temperature down one click. Okay, so we could have that all automated in this program, where it basically turns it down and keeps turning it down until it gets that down, and turn it down and wait 5 minutes, check the temperature. So again, that could all be part of one program, and with no human involvement at all. So any questions on that? Okay. Okay, so now we can use, the next example is how we use the while loop for input validation. So, one of the most famous computer industry sayings is garbage in, garbage out. It says, if we put garbage in, we're going to get garbage out. So what we need to do in order to keep from getting garbage in, we want to basically make sure we validate the input before we actually utilize it. So if we take a look at this, I've got an input J option pane, and it says enter the number in range 1 through 100. Now, if I type in a number that is not in that range, I want the user to try it again. So what we do is we use a while loop. The while says while number is less than 1 or number is greater than 100. So if either one of those true, we're going to come back and get another input from the user and say, hey, input, an invalid input, enter a number in the range of 1 through 100. We convert that input into an integer, we put it into number, and we come back and we appear in this while loop and we try it again. So this is the example I was talking about earlier, where we want this to be false. Okay? We want this to be false because we want a valid number between 1 and 100. So the meat of the code is after this while statement. So I think they actually have an example. Yeah, so here's what it is. So we read the first value, we come in, is the valid invalid? Is the value invalid? If it is, we're going to display the error message, and then we're going to actually ask the user for another value, and we come back and check it again. We're going to keep doing this until it's false. Once it's false, we're going to drop down here and then go into the program that utilizes that number for something. So let's take a look at soccerteams.java. And here's my class soccer teams. Here's my public static void main. I've got a couple of constants. I've got min players and I got max players, 9 and 15. I've got I got 4 integer variables: players, team size, teams, and leftover. Then I've got string input. So we got string input because we're using a J option pane. So my J option pane says enter the number of players per team. Then we take that input, we convert it to an integer, we put it in a team size. And we say while team size is less than min players or team size is greater than max players, we're going to say, sorry, that number must be at least min players and no more than max players. And then we ask the user to get it again, feed the input of the J option pane, we convert that input to an integer, put it in the team size, and it will loop again to see if this statement is true. We want it to be false. Okay? So once we get past that, now we're going to add numbers that are 9 or between 9 and 15. Then we could come in here and say enter the number of available number of players. We put that into input, we convert that into an integer, we put it into players. And it says while players is less than 0, so this is another input validation. It says we need to enter 0 or greater. And once this statement is false, we're going to get out of that. So this is going to make sure that we type in something that's 0 or greater. Then I say teams equals players divided by team size. Leftover equals player divided by team size, and the remainder of that division will be put into leftover. Then our J option pane message dialog will display there will be teams with leftover players left over. And again, we do a system.exit 0 because it's a J option pane. We want to make sure that that is killed. I did read, I don't know if I read that to you, but basically there is a warning for this system.exit 0, so we shouldn't use this all the time because it does kill the JRE. It does kill the entire Java runtime environment. So the only reason we're using it here is because of this J option pane. We want to make sure that it kills the J option pane that is currently running, but realize it kills everything. So let's go ahead and run this and enter the number of players per team. I'm going to say 5. I'm going to hit the OK, and it says, oh, that number must be at least 9 and no more than 15. Enter the number of players. Okay, we'll type in 12. Enter the number of available players. I'm going to say -2. And it comes back and says, oh, you got to enter 0 or greater. Okay, I'm going to say we have 67 people available. I click OK. It says there will be 5 teams with 7 players left over. So, pretty cool. Click OK. So we put the number of players per team. It figured out by the total number of people we give. It figures out how many teams we'll have and how many people left over. And we can take those people left over and we can probably break them up and divvy them out to the rest of the teams so that maybe they have 1 or 2 extra. So any questions on that? We're just basically taking and using a while loop to validate the input that the user gave us before we actually use it. Like I said, we want those while loops to be false before we actually go into the program. Okay, so we've talked about a while loop. Let's talk about a do while loop. So sometimes, no matter what, we want to do this loop at least once. With our while loop, since it's a pre-test loop, if that statement is false, it won't even go into the loop. But let's say there's a situation where we want to do this loop at least once. So this is where the do while loop comes into play. And this is what it looks like. We've got just do. We've got statement, how many statements we want to do. Then we check the while at the very end of the loop. So what that means is the do says do these things, and then we check to see if that Boolean expression is true or false. So that means it's going to do these statements at least once before it checks it. So let's take a look at the test average. Yeah, and so if you want to see what a do while loop looks like in a flow chart, notice we come down, we do the statement first, then we check the Boolean expression. So you notice the statement is before we get into the loop, as opposed to being over here on the true side. So let's open up test average 1. So here I get my public class test average 1. Here's my public static void main. This is my executable method. And I've got 3 int variables. I've got score1, score2, and score3. I've got a double variable called average, a char variable called repeat, and then I've got string input. So the first thing it does, it displays a message that says this program calculates the average of 3 test scores. We're going to use the scanner keyboard. Notice I've got a do loop right here. The do loop says just do this. So we come in, it says enter the score 1, and we basically use the keyboard next int to put that, whatever we type in, to score 1. We do the same thing for score 2 and score 3. And then notice we clear out the keyboard buffer, because remember, once you hit the enter key, that new line enter key is sitting right here in the keyboard next line. So we want to clear that out. And now we come in, we say average equals score 1 plus score 2 plus score 3, and divide that whole total by 3. And then we say the average is average. And then we print a blank line. And then we say, would you like to average another set of test scores? Enter Y for yes or N for no. Now, look at this. We're doing input keyboard next line. We did that because we were grabbing data up here. We basically closed out or cleared out the keyboard buffer, and we're basically now grabbing that, whatever we type in, to put it into input. Now, somebody could type YES or they could type NO. We don't care. We're just going to grab the very first character of that. So I say input.char at 0. So it says grab the very first character, the 0 character, put that into repeat. And notice here's the while statement now. The while statement says while repeat equals uppercase Y or repeat equals a lowercase y. If that's true, we're going to come back in and start at the do again. If we typed anything else, it's going to drop out of the loop. So the difference between a do while and a while loop is the check in a do while loop. The while is at the end of the loop. So that's where it checks to see whether it needs to go and do it again. What that means, though, is the very first time you come into it, it's going to do this at least once. So if we click on the run, it says this program calculates the average of 3 test scores. So let's type in 97, 86, and 72. I hit the enter key, and it says the average is 85.0. Would you like to do another average? I'm going to go ahead and type in a lowercase y and hit the enter key, and we can type in another score. We'll type in 89, 92, and 93. We hit the enter key, and the average is 91.333. Would you like to average another set of test scores? Y for yes, and for no, I'm going to type a lowercase n, hit the enter key, and the program is done. So, with the do while, executed at least once, and then it goes into the loop. So any questions on the do loop? Okay. Yep. Is there anything down here? No. Now, the next type of loop is called the for loop. And the for loop is a lot different than the other two loops in that it is ideal for performing a loop of when we know the number of iterations it's going to execute. And we'll talk about that here in a second. So here is, well, let's just do this. Let's just open up, let's just open up squares.java, and I'll talk about it. So public class squares. Here's our public static void main. We've got int number, so we've got one variable. I print number space 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 and then number squared, and I'm going to put an underline underneath of it. Now here is what a for loop looks like. It's got 3 parts. The first part is the variable. It says this part right here, where it says number equals 1, that gets executed at the very beginning of the loop. And it only gets executed once at the beginning when we first come into it. The second part, number less than or equal to 10, that is the check. That's the test at the beginning of the loop, of every loop. Okay? This has to be true in order for it to go into the for loop. So that gets checked every time. The very next one is number plus plus. It adds 1 to number. That always gets executed automatically at the end of every loop. So the first part gets executed once at the beginning. The second part is the check at the beginning of every loop. It's a pre-test loop. And the last part, the third part, gets executed at the end of every loop. So if number is set to 1, is 1 less than or equal to 10? Yes, that's true. So it comes in here and it says number, tab, remember the /t and the /t, that's a tab key, is number times number. So it's going to put the number here, whatever that is, and then number times number underneath this column over here. Then it adds 1 to number and it comes back up to the loop. Now number is a 2. Is 2 less than or equal to 10? Yep, it's true. It's going to come in, do the same thing again, This gets executed at the very end of the loop. So now it adds 1 to number. Now it's a 3. Prints that. It's a 4. Prints that, and it keeps going until it's greater than 10. Because if it's equal to 10, it's going to come into this loop because that number is less than or equal to 10. So let's run it and see what it looks like. And this is what it does. So there's the number and number squared, and there's the line to split that off from the column headings. And 1 times 1, and 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth, all the way down to 10 times 10, or 10 squared is 100. So the for loop, very, very powerful. We basically set everything up in these parentheses right here. We could even do this. I could even say int space number. I could declare that variable directly inside of the for loop. I don't have to do it up here. So that's possible as well. That's a possibility. So any questions on the for loop? Okay. So the for loop in a flow chart would look like this, where we assign number 1 to a number, and then we come in. So it looks really a lot like a while loop. So it's hard to tell the difference between a while loop and a for loop inside of a flow chart. And by the way, when I first started programming in college, we literally had a template, a little plastic template with all of these symbols on there, and our instructor told us to buy one of these big long eraser pencils. All it is an eraser, and basically lots of pencils, and we actually had to draw, and all of our logic had to be done with these flow charts, and that's how we basically learned logic. And I went through a lot of erasers that semester. So yeah, nowadays we can do this flow charting online through software. So it was not a lot of fun. Okay, so the for loop is a pretest loop, meaning that if this was set to 11 right here, so if number was equal to 11, it's not even going to go into the loop because 11 is not less than or equal to 10. That's false. That's going to basically go right past this loop. So it's just like a while loop. It's a pretest loop. Yeah, again, it says avoid modifying the control variable in the body for the loop. So if I have x equals 1 right here, and I'm adding 1 to x right here, don't add to x down here, because it's already getting added to. So if we did this, it's going to be adding 2 every time, because this is going to execute right here, and this is going to execute as well. So it's going to add 1 and then add 1 again. So realize we don't have to do that like a while loop. That's what the for loop does. It automatically increments for us automatically. Now we could do that. We could start with the number 2, and while number is less than or equal to 100, we're going to print the number, but this time we're going to add 2 to the number. We're using the plus equal here. So number plus equal 2 adds 2 to number. So this is going to print 2, 4, 6, 8, 10, 12, all the way up through 100. We could do it backwards as well. I could say number is equal to 10, and while number is greater than or equal to 0, while that statement is true, we're going to print the number, but this time we're going to subtract 1 from the number. So number minus minus subtracts 1 from the number each time. So first time through is a 10, then 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Now, I said this earlier. We can declare this variable inside of the for loop. I can just say int number equals 1. I don't have to declare outside of the loop. I can actually do it right here inside of the for loop. Because remember, this first part gets only executed once at the very beginning. This is the check at the beginning of every loop, and so what happens at the end of every loop. Okay, so we got so let's open up user squares. And this is just like the previous program, except now we're going to ask the user, how high do you want to go? So it asks right here, how high should I go? And it's going to grab that and put it into max value. And then it's going to print the headers, number, and number squared, the dotted line. And then we got our for loop. This time, notice, remember in the last one it said number less than or equal 10? Well, now, this max value we got from the user, that's how high we're going to go. So, so again, remember this first part, number equals 1, that gets executed at the very beginning only once. This is the check at the beginning of every loop, and this part gets done at the end of every loop. So we come in here, we basically type the number. Again, it starts with 1. We tab, and then we put number times number. And we're going to do that all the way up to whatever we typed in for the max value. So let's run it. And let's type 25. I hit the enter key, and look at that. So it's going to show the number squared from 1 through 25. And we can see that 25 is 625. So 25 times 25, number squared. Any questions on that? Okay. Now, we could do something like this. We could have 4 parts to for a for loop. I can say x equals 1 and y equals 1, and while x is less than or equal to 5, we're going to add 1 to x. Okay. But notice we still only have 2 semicolons. We have a comma for the first part between those two. So we initialize x, we initialize y, and then we come in here and we say x plus y equals x plus y. And again, what we're going to do is y is 1, and we're basically showing what 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, and 5 plus 1. We're going to see what those each look like by doing this. So we can use, on the initialized side over here, we can put more than one variable in there. We can also do this. On this right-hand side over here, we can actually increment two variables. Again, separated by a comma. We still have just 2 semicolons because we have 3 parts. Here's part 1, part 2, and part 3. So part 1 has initialize of x and y, and this is our check at the beginning of every loop, and these 2 get executed at the end of every loop. So this is going to be 1 plus 1 equals 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, and it's going to basically look like this right here. 1 plus 1 equals 2, 2 plus 2 equals 4, so on and so forth. Now this next in the spotlight is kind of cool because what we need to do, since your friend Amanda just inherited a European sports car from her uncle. Amanda lives in the United States, but she's afraid she'll get a speeding ticket because her car's speedometer indicates kilometers per hour. She's asked you to write a program that displays a table of speeds and kilometers per hour so she can convert those miles per hour to kph. Okay? So miles per hour equals kph times 0.6214. So as in the formula, the speed is miles per hour, k per h is kilometers per hour. The table should look like this: kph and mph, and we're going to show 70, 60, 70, 80, so on and so forth, and we'll show the equivalent of miles per hour, what that is on the right-hand side. So let's take a look at speed converter. So public class speed converter, we got public static void main. We've got three constants. We've got starting kph, which is an int, a 60. Max kph is 130, and increment is 10. So I've got int kph and double mph. Now the reason it's a double is because guess what? We're multiplying by a decimal place, so it could be most likely have decimal places. So we're going to type our heading, which is kph tab mph, and we've got our dotted line, our dashed line there. Now here's our for loop. kph equals starting kph, which is 60, while kph is less than or equal to max kph, which is 130. We're going to go into the loop. At the end of every loop, we're going to say kph plus equal increment, which is 10. So in this case, we're going to go by tens. We're going to go 60, 70, 80, 90, 100, 110, 120, 130. So once we cut, so if this statement's true, so if this guy right here is true, we're going to come in here and we're going to say mph equals kph times 0.6214. Now, I don't know why they didn't make this a constant. I would have made that a constant as well, the 0.6214. And then we're going to display. We're going to use a printf. So we're using a printf. So here's our %d. Here's our %f. So the %d is going to be kph. We do tab, then we got %.1, so we're going to round to 1 decimal place, and that's where the mph goes into that %. So we're going to display that for each line. Let's go ahead and run it. And there we have it. So there is our headings, kph and mph, and there's our line underneath our columns. So 60 mph is 37.3. 70 kph is 43.5. 80 is 49. So really, look at that. 100 kilometers per hour is really just around 60 miles per hour. 130 kilometers per hour is 80. So, so big difference between kilometers per hour and miles per hour. So the main thing there that I want you to really kind of take away is, so we're using a starting kph, which is our constant, and while that is less than or equal to our max kph, we're going to come into this loop. But the big thing here is we want to increment by tens. We're incrementing by 10 and not just 1. So kph plus equal increment, which is 10. So again, we start at 60, we go to 70, then 80, 90, 100, 110, 120, 130. Okay, this is probably a good time for a lab. So this next, section is this thing called running totals and sentinel values, and I'm not real keen on the sentinel values, but let's just cover it just for the sake of the book. So running totals is the sum of numbers that accumulates with each iteration of the loop. The variable used to keep the running total is called an accumulator. The sentinel value is the signals the end of a list of values that have been reached. So here's the flow chart for what they're talking about. So I've got an accumulator. Now whenever we use an accumulator, we have to make sure we at least set it to 0 in the very beginning. So I say set the accumulator to 0. Then I come in and say, is there another number to read? Yes. I read that number, then I add that number to the accumulator, and I come back up. And is there a number? So I keep doing that as long as there's another number. Once I get done, I come out of here and it's false. I don't add anything to it anymore. So let's open up total sales to see what that looks like. So total sales, public static void main, we've got one int, days, we've got two double variables, sales and total sales, and then we have string input. We're using the decimal format dollar to format our numerics to make sure that it rounds to 2 decimal places and use 1,000 separator. We use a J option pane for how many days did you have sales figures. That gets put into input. Remember, that's string, so we have to convert that to an integer. So we use the integer.parseInt to convert input to an integer, and we put that into days. Now we come down here. Here's our total sales. Okay, this is our accumulator. Before we can add to the accumulator, we have to always set it to 0 first. If I did not do what was on line 28 and I tried to add to total sales, it would error out because before I put 0.0 in here, it has a null value. That is a hexadecimal 00, which is nothing. We can't add numeric values to nothing, so it would error on us. So we got our total sales set to 0.0. Now I've got my for loop. I create an int count and we initialize it to 1. Remember, this first section right here gets only executed once at the beginning. Here's my test. Count less than or equal to days. Okay? The days is what we get from the user. The count gets incremented to once at the end of every loop. So once we go into this here, we're going to ask the user, enter the sales for day 1. Okay? First time through, it's going to be 1. Then day 2, then day 3, all the way up to the number of days we do. Now remember, this is a string, so we need to convert this to a double. So we use the double.parseDouble that converts the input to a double. We put that into sales. Then I say total sales plus equals sales. That adds sales to total sales. We come back around, we're going to keep doing this for each number of days that we typed in for days. Once we get out of there, we go ahead and use a show message dialog to say the total sales are $. This is where we use the $.format total sales. So it's going to round to 2 decimal places and put in 1,000 separator. And again, since we're using a J option pane, we always use the system.exit 0. So let's run this. And how many days do we have? Let's go ahead and type in 5. And the sales for day 1 were 2,356.25. Day 2 was 5,611.78. Day 3 we'll say is 4598.62. Day 4 is 7100.45. I'm just making up numbers. If you want to try your own, that's fine as well. And the last day is 6923.82. I click OK. It comes back and says the total sales were $26,590.92. That's formatted really nice with the decimal format right there. Click OK. System.exit 0 executes and the program ends. So the whole point of that is this total sales. Before we can use the accumulator, the very first thing we have to do is we have to set it to 0, 0. Now, what we could have done that here, where I said double total sales, and I could have said equals 0.0, and we have to do that down here then. But it's always kind of a nice thing before we go into a for loop like that, is to make sure we have that accumulator set to 0.0. Okay. So that was the total sales. That's our accumulator. Now let's talk about using a sentinel value. So in this case here, we're going to ask the user for data, but we're going to let the user tell us when we're done putting data in. And that's where they come up with a sentinel value. So let's open up soccerpoints.java. Let's take a look at this. So inside of our public static void main, I've got int points, int total points equals 0. So it looks like total points is our accumulator. We initialize it to 0. I got a scanner keyboard, and I do a println, enter the number of points your team has earned for each game this season, enter -1 when finished. That is our sentinel value. Our sentinel value is -1. When we type in -1, the program ends. So, or they should say the loop ends, which causes the program to end. So we then display enter the game points or -1 to end. We then grab those points using the keyboard next int, throw them into points. And it says, while points are not equal -1, we're going to basically add the points to the total points. And then we're going to add the user for the next set of points, again, telling them to enter a -1 when we're done. So it's going to keep looping and looping and looping until it gets that sentinel value of -1. Once it reaches a -1, it's going to drop out of this loop, and then it will display the total points are, and then display the total points that we have been adding to. So let's go ahead and run this. And we're going to type in, we'll type in 56, 23, 78, 62, 91, and then I type in a -1, hit the enter key, and it says the total points were 310. So the whole point of that exercise is the -1. That's a sentinel value. Is it always going to be -1? No, it can be anything you want. You could actually ask to type in the letter A. But if you typed in the letter A, what's going to happen? Well, it basically, well, we could use the char, because a char is a numeric value. So I could use a char to say, enter the letter such and such to basically get whatever. Well, we'd have to do next char though. I'd have to do next char to say this. Yeah, it wouldn't work for this program. But it could be a 1, it could be a -2, it could be anything we wanted to type in. -1 just happened to be a good point, because we can't get negative points in a game, scoring in a game. I should say. Well, is there any games that use negative numbers? I don't think there are. So that's why they're using a -1 as the sentinel value. So any questions on the sentinel value? I would say the best way to do that is you would have to do this. All of your inputs would have to be strings, and then you would convert them to an integer. So that way there you could then use a letter as a sentinel value, right? Because right here, we keep asking for points equals keyboard next int. It expects an integer in this particular case. Now, if we use the J option pane, that's a different story, right? because the J option paint, everything it gets is a string. So a J option paint would almost be ideal in that case, because we could do the test before we convert it to a number. Yeah, that would be a little tricky there too. Yeah, yeah, but it well, so here's what you're talking about. You're talking about using a try catch statement, which we aren't going to cover for until a couple chapters from now. But yeah, we could do that with a try catch statement. We could say, hey, if it's not an integer, that's our sentinel value, and that would be the basically the case to go ahead and kill this program. But yeah, so yeah, there's ways to do it. There's ways to do it. But for what we know right now, we would have to basically get everything as a string as input, and then check to make sure it wasn't a string, and then add it to our total. Okay, good analogies. So last thing we'll cover tonight is this thing called nested loops, and these are kind of cool because they're kind of cool and they're kind of complex because you really got to think of when you got a nested loop inside of a nested loop. When is that outside loop going to basically get incremented? Not until that inside loop completes. So this is a clock. So this is a great example of a clock. So let's open up the clock.java. And so here's what we've got. So inside of our public static void main, I've got 3 for loops. Notice they're inside of each other. So the first one is int hours equals 1. While hours is less than or equal to 12, we're going to go into this loop. At the end of this for loop, we're going to add 1 to hours. Now realize that's not going to happen until you hit this brace down here. Okay? So just keep that in the back of your mind. So the very next loop says int minutes equals 0, and while minutes are less than or equal to 59. At the end of every loop there, we're going to add 1 to minute. Again, that's not going to happen until it hits this bottom brace down here. The next loop is for int seconds equals 0. While seconds are less than or equal to 59, we're going to go into this loop, and we're going to add 1 to seconds at the end of that loop, which is this right here. So here's how it works. So we come in this first loop, we set hours equal to 1. We set minutes equal to 0, and then we set seconds equal to 0. So I'm using a printf. So I've got %02d. So it's going to have, so what is that doing? That says, guess what? I'm going to have a leading 0, and the max width is 2. So what that says is if the width is less than 2, it's going to have a leading 0. If it's got 2 digits, it's going to display both. Then I've got colon. Now here's my next printf, and that's also got a leading 0, max spaces of 2, and the d again is expressed in a decimal integer. And then colon, here's my third %, which is leading 0, max 2, and it's expressed in a decimal integer. Here's our new line character. So hours is going to go into this first %, minutes is going to go into the second %, and seconds is going to go into this third %. So here's how it's going to work. When we come into this first loop, it's going to print 0, 1, 0, 0, 0, 0. It's going to then increment seconds and come back around because now seconds is 1 less than or equal to 59. It is. Well, We haven't incremented hours yet, so hours are going to stay 0, 1, 0, 0, 0, 1. Do you see, kind of see what's going on now? So it's going to keep doing, so it's going to keep incrementing seconds until seconds gets to 59. So once seconds are 59, we add 1 to it. Now it becomes 60, and it comes back around, and it drops out of this for loop, and basically hits this into this for loop, the minutes, where it increments minutes by 1, which causes it to go into this for loop again. So it starts this for loop all over again. So now hours are still 0, 1, minutes are now 0, 1, and seconds are 0, 0. Come back around, 0, 1, 0, 1, 0, 1. Come back around, 0, 1, 0, 1, 0, 2, 0, 1, 0, 1, 0, 3. So you kind of see what's going on here. So if we run it, it's going to go pretty quick. Boom. And our console, it doesn't display a whole lot. I think it's going to go all the way up to the 10s, maybe. Does it go all the way? Yeah. Yeah. So as you can see here, the hours were set to 10, 0, 0, 15, 16, 17, and all the way down here. So look, here's 57, 58, 59. Boom. It drops out of that seconds loop, goes and increments the minutes loop, and then executes the seconds loop all over again. So now it's 10, 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, until it hits 59 again. And then it drops, then it goes 10, 0, 2, 0, 0, the 10, 0, 2, 0, 1, 0, 2, 0, 3. Now, what would really be cool is we do have a timer object. We don't cover that in this class, but if we could get a timer object in here, and up here in the code, what we could do is after this sys out statement, we could do a timer statement that actually basically run 1 second. It would basically timer 1 second, actual 1 second, so that we could actually see the clock then go. It would go tick, 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 tick. And we could actually have a running clock right here. So that'd be kind of cool. So any questions on the nested loops? Right. And what you also got to realize is once it gets done with this seconds loop right here, it increments this minutes loop, and then it does this for loop all over again. And same way with the minutes. Once it gets down to the 59th minute and increments, it'll basically drop out of that loop and actually come back up to the hours, where it increments the hours by 1, and then it executes this loop over again and this loop over again. So this seconds for loop is going to be executed a ton of times. Well, how many seconds are in 12 hours? That's how many times that for loop's going to execute. How many times is this minutes loop's going to execute? Well, it's going to execute 60 times, 60 times. Well, 60 times 12, basically. And this hours loop is only going to execute 4 times. It's only going to loop 4 times. So pretty cool. Okay, does anybody have any questions?